Thank you for watching this video. In this work, we consider generative adversarial nets, or GANs, which are very popular nowadays for performing unsupervised generative modeling, especially for the natural images. We propose a possible solution for one particular problem of GANs commonly reported in the literature, which is the mode collapse, a situation when the trained GAN model generates only a certain part of the data and ignores most of the modes. Imagine the following toy example. You have a corpus of pictures of animals and you want to train a generative model. You run GANs and end up with a model generating pretty decent pictures of penguins, but unfortunately it does not generate many other animals, for instance giraffes. You could manually remove all the pictures of penguins from your dataset and run GAN again. This time the GAN would have no choice but produce new animals. By iterating this process, eventually we arrive at a model generating giraffes. At the end, we aggregate all the models obtained during these iterations. We could turn this procedure into an automatic approach. Instead of including or excluding pictures from the dataset, we can put continuous weights on them. For that, we train a classifier separating images of the original corpus from the synthetic images generated by the current mixture model. We can use the outputs of this classifier on the data points to reweight them. Classifier makes confident predictions when the true data point is not surrounded by the generated data. That is, we missed it. If classifier is not confident, it means we already covered this point. We make the above-mentioned argument formal by studying an approximation of probability distributions with finite mixture models and arbitrary F divergences. Given T components together with their weights, choose a new component so that the updated model will approach the true data distribution as close as possible in the F divergence. We provide an optimal update Q star, obtaining the global minimum of this functional. We show that using optimal updates on every iteration guarantees an exponential convergence to the true data distribution, and we also provide a similar analysis for the approximate updates. This theory leads to the AdaGAN, iterative algorithm for constructing mixture models. At the t plus first step, we need to match the distribution Q star specified here. Unfortunately, it depends on the ratio of densities between the current mixture Pg and the data distribution. We estimate this ratio with the adversarial training, reweight the training set according to the logits of the discriminator, and train next GAN by importance sampling according to the updated weights. The experiments on synthetic dataset and MNIST show that AdaGAN can be successfully combined with any implementation of GANs to improve their coverage.